Now let's switch over from hydrostatics to hydrodynamics. In this branch, we normally study regarding the flow of fluid. You might say fluid in motion. When it comes to flow, it could be classified basically in three categories. One is a streamline or steady flow, the other would be turbulent, and finally, laminar flow. In steady or streamline flow, all the liquid that will pass through a point will always have the same velocity. That means you could say the speed at any point doesn't change with time. This could also be defined by saying that every particle passing through a point will follow the same path. So, this is what we call a streamline. You see, when in a pipe there is a smooth flow of water, it is a very good example of a streamline flow, but this has to be maintained by keeping the velocity low. Magnitude of the velocity should be low. In turbulent flow, you see, it's a very zigzag. It's shown over here. When you start boiling water in beaker, convection takes place. There is no well-defined path. Any of the liquid molecule at the bottom will get heat and go upward by any path. So the path there is not well defined. That becomes turbulent flow. When the smoke rises in chimney, it's not a well defined track. So that's also the case of turbulent flow. When you say turbulent means chaotic, means unsystematic. So if it is not a streamline, obviously it has to be turbulent flow. A very good example is natural convection. Then, for example, you might have seen vortices or eddies, vortices regarding air with the air and eddies with the water. These are very unsystematic flow of liquid and air. These are the examples of turbulent flow. In laminar flow, you see, the flow is always parallel to each other in the form of parallel layers. Liquid will move in the form of parallel layers. You see the blood flow in capillaries inside the human bodies, that's also a very good example of laminar flow. I have tried to represent this one by the help of vector. These are the parallel vectors. As you follow the method for showing uniform electric or magnetic field, similar is the method here to represent laminar flow. You see, when the flow is going to be streamline or turbulent for that thing, we have chosen a particular number known as Reynolds number. Reynolds number is equal to rho V d upon eta. Rho is the density of the liquid flowing fluid rather fluid you could say in motion, means this is true for liquid and gases both. V is here the velocity of the liquid in flow, d the diameter of the pipe, and eta we shall study later on, that's coefficient of viscosity. By calculating this value, we could make sure whether the flow would be streamline or turbulent. If it is less than 2000, it's going to be a streamline flow. If it is greater than 3000, certainly it will be turbulent flow. And in between, that is 2000 and 3000, the flow is neither streamline nor turbulent. You could say this is transitional phase, means it is gradually switching over from streamline to turbulent flow. So this is a very good demarcation for these kind of flow. Now, point wise I have tried to explain these flow by putting the condition and example. You see, all I have told you, you could take one by one, like steady flow, velocity is constant with respect to time, water in pipe, and so on. Everything I have explained, you could just see that thing or revise in tabular form over here.